In today's video, we'll be exploring some more functions of scikit-learn. Before moving forward, I'll be discussing the question that why is shuffling necessary? By shuffling your data, you ensure that each point creates an independent change on the model without being biased by the same points before them. As I explained, you shuffle your data to make sure that your training and test sets will be representative. In regression, you use shuffling because you want to make sure that you are not training only on the small values, for instance. Shuffling is mostly a safeguard. Let us understand this by an example. Suppose the data is sorted in a specified order. For example, a data set which is sorted based on their class. So if you select data for training, validation, and test without considering the subject, you will select each class for different tasks, and this will fail the process. Hence, to impede these kinds of problems, a simple solution is shuffling the data to get different sets of training, validation, and test set. Now that we have seen how to take the data set and how to split the data, we'll be moving forward to other functions of scikit-learn, which is pre-processing using scikit-learn. Now, the different methods that we'll be discussing are binarization, mean removal, standardization, scaling, normalization, and encoding. So we'll be moving forward to our Jupyter screen and we'll be coding them one by one, and I'll be explaining them to you. So first of all, let us understand what pre-processing is and why it is important. So as we are dealing with lots of data, and that data is in raw form. So before importing that data to machine learning algorithms, we need to convert it into meaningful data. This process is called pre-processing the data. So scikit-learn has a package named pre-processing for this purpose. And the pre-processing package has the following techniques, which we'll be discussing further. So data pre-processing is important because data in the real world can be incomplete, noisy, inconsistent, and duplicate. So without wasting any more time, we'll be moving forward. So this will be the input number data that we'll be having, and this will be the categorical data that we'll be having. First of all, let us try and use the binarization method. So for that, what will I do is that using the pre-processing package that we have, we will call binarizer. And in the binarizer, I will set the threshold is equal to 0.5. So in binarization technique, we use it to convert our numerical values into Boolean values, right? And to convert this, we use a threshold value. So this, anything below this threshold value goes to 0 and anything above this goes to 1, right? And thereafter, we transform our input data as per the binarizer. And let me just print D1. So this is the output that we are getting. Our threshold is 0.5, and this is the array that we have as the input. So since 1 is greater than 0.5, we have 1. Minus 1 is less than 0.5, thus we have 0. 2 is greater, and thus 1. And this is how rest of the values come. So this is what binarizer is. Next, we have mean removal. Now, simple linear prescaling of input variable is done in mean removal, and this is done so that datasets don't have a lot of variation. So in this process, mean should be near to 0 and standard deviation should be near to 1. So how do we perform this is, first of all, let us see what is the mean before pre-processing. So I will take my input data and then I'll write mean. And during pre-processing, we work near to feature data. So all these features are actually the columns. to represent a column, we write axis is equal to 0, right? And so this is the mean that we are getting for the first, second, and the third column. So let us just look roughly. So 1 plus 2 plus 0 is 3. 3 divided by 3 is 1. That is why we are getting 1. Minus 1 plus 0 plus 1 is 0. 0 divided by 3 is 0. And 2 plus 0 plus minus 1 is 1. So 1 divided by 3 is 0.34. Thereafter, let us see what will be the standard deviation of our input data, and we'll be seeing this along the axis 0 itself. So this is the standard deviation that we have. The next thing that we'll be doing is that we'll be pre-processing our input data. So we do pre-processing dot scale, and in this we write our input data. So once we do this, this is the output that we'll be getting after the mean removal. The next point and method that we have under pre-processing is standardization. So in standardization, we calculate the z-score value. So z-score value is z is equal to x is a data point, mu is our mean, and divided by standard deviation. So we did calculate the mean and standard deviations for the data. Now let us perform standardization. So for this, what we do is P3 is equal to pre-processing dot standard scalar. We call that, and with this, we want to fit our data, right? So after this, we fit our input data into this. Let us try and print the value of T3. It is showing us standard scalar, but to show the actual values, we have to write D3 dot mean. This will give us the mean that we had actually calculated, right? But now I want to transform my data using standard scalar. So how do I do this? Is I write D3 dot transform, and then I'll write my input data. And I will print this. So this is the transformed data that we are getting, and if you see, it is quite similar to the mean removal stuff that we did. So it is the same thing, but different functions and the ideas for it. The next stuff that we'll be learning is called scaling. Now imagine that you have columns wherein some of the columns, the values range between 0 and 1, and the other column, it ranges from 1000 to 2000, and in the others, it ranges in lakhs. But while I'm processing, I need them to be in a single range. So how do I do that? So to bring all the values within a range, we use min-max scalar. So it is an alternative to standardization where the pre-processed data lie between a given minimum and maximum value. So often this minimum and maximum value is 0 and 1, or we can have any other min max value according to our problem's demand. So the formula for the same is, if we want to calculate, then x dash will be equal to x minus the min of our data, and that will be divided by max of the data minus min of the data. All of this is multiplied by new max that we have selected minus new min, and this value will be added to new min. So this is how we'll be doing it. Now, if we go ahead and look at the code, what do we have to do is we write T4 is equal to then pre-processing Then, as I told, we'll be using min-max scalar. So we'll be calling min-max scalar, and then we'll have to keep the feature range. So feature range, let us keep this between 0 and 1, right? So this is the data and it ranges from -1 to 2, and we want to transform this data between 0 and 1. So we do this, and thereafter we do fit transform our input data. That we do have to pass on the data wherein we want to do this processing, right? And we'll be seeing the output. So now the data, which was earlier this, has been changed to this data after pre-processing, and we have brought it into the range of 0 to 1. The next process is a very interesting process, and it is used highly into the machine learning problems. It is called normalization. So this processing technique is used for modifying the feature vectors, which is axis is equal to 0 and our column vectors. And normalization of feature vectors is necessary so that feature vectors can be measured on the common scale. So we have to process for it. First one is L1 normalizing, and it is also called least absolute deviations. So it modifies the values in such a way that the sum of the absolute values remains always up to 1 in each row. So what does this mean is, let us quote this and understand. If we have d phi is equal to pre-processing, and thereafter I will be calling normalize, and on the input data we want to do, right? So input data, and the normalization method is L1. Thereafter I will be printing it. So let me just take this value and I will add it. So this ranges to 0.5. For the next, if we do, it is quite clear to see that the summation value will occur to 1. So this was something that we had discussed, that it modifies the values such that once we add the values in the row, it should come near about to 1. So this is what L1 normalization is. Similarly, L2 normalization. So in L2 normalization, it is also called least square, and the only difference from L1 normalization is that it modifies the values in such a manner that the sum of squares remains always up to 1 in each row. So what does this mean is, we just copy this and print a value and show you. And we'll just change the normalization technique to L2. This is the value that we are getting. So what we'll be doing is that we'll be taking the square of each and adding them. And we'll be taking np dot square root of this whole. So this should also come near about to 1, and as we see that the value is 0.8164, and it is quite near to 1. And for the next row, if we see, it is quite clear if we see. So it will be 1 square plus 0 square plus 0 square, and the square root of that will equal to 1. So this is what our L1 and L2 normalizations are. The next thing is encoding. Now, all of these things that we have performed is under numeric data. But what if I want to encode and pre-process my categorical data? So for that purpose, we use encoding. So categorical data can be male, female, Asia, Pacific, right? So one of the method under encoding is one-hot encoding. So this transforms each categorical data with n categories. So this is a very important term here. it converts into n categories, possible values into n category binary features, all ranging between 0 and 1. So we have already taken this data over here, which is X, male from US uses Safari, female from Europe uses Firefox. Right. Now, what I want to do is that I'll be doing one hot encoding. So let me just take D7 is equal to preprocessing dot one hot encoder, and I'll fit my X into this, right? So once I do this, I have to then transform my data. So let me just do it in the next step. So my D7 will be equal to D7 dot transform. So what do I want to transfer? For example, let us take the example wherein we have female uh, from US and uses Safari, right? And the other input we can have is that we can have male from Europe and he uses Safari. So as per the input, we'll have to change this. And once we do this, we have to convert our output to array, and thereafter we print it. Okay, sorry. So yes. So this is the output that we are getting. So let me just copy this here. So what we had is male from US uses Safari, female from Europe uses Firefox. So in this case, it is matching from where are we getting this, right? So first of all, we have female from US and she uses Safari. And this is how it is matching from these values and it is giving us the output. So we have female, then we have from US and she uses Safari. So we are adding one to the points where we are matching the data points. So this is what our one hot encoding is. The next example that we have and the method that we have under preprocessing is label encoder. So it encodes target labels with values between 0 and n classes minus 1. So we'll be having classes and we have to encode between 0 and the classes minus 1. So how to this work is, let me just take the example as D8 is equal to preprocessing dot label encoder. Okay. Thereafter, let me take the data as we'll fit the data as let us have we have Paris, then let us again have Paris, then let us have Tokyo, and thereafter let's have India. Thereafter, what will be, just let us see that what are the classes, right? So we'll do DA dot classes. So these are the different classes that we had identified. As we are able to see that Paris is repeated twice. So we are just taking the set of the values. And thereafter, let us transform this data and let us see what does it give the answer for Tokyo. Then again Tokyo, and then again Paris. And let's just print this, and thus the value that we are getting is 2 to 1. How are we getting it? 0, 1, 2, 3. Tokyo comes at the place 2. So 2, 2, 0, 1. So we are taking the first value over here, and that is how we are getting Paris over here. So this was all about pre-processing. In the next video, we'll start over with the features that we had learned for scikit-learn.